Building science is the study of the technical performance of buildings, including their materiality and behavior. It relies on physics and chemistry and material science to understand concepts like heat, air, and moisture, sustainability, and energy efficiency. Building science can help address issues like moisture management and thermal performance using our analysis tools to figure out where vulnerabilities lie, whether it be with condensation or moisture accumulation over time, and then help a project team organize materials on their project in a clever way to avoid those problems in service. Clients come to us with all of their problems, whether they range from the most simple problem to the most complex, and we can help them determine, say, what an appropriate or maximized wall section is for a given climate or project. And then we can also do very complex problems, including analyzing air and heat transport through a computational fluid dynamics simulation tool. One of the most challenging projects that I've been on recently was the Hirshhorn Museum. It was a brutalist landmark from the last century, and we had to figure out why condensation was forming in these discrete periods of time, and it really turned out to be a two-dimensional problem, which people did not anticipate. And we used a combination of analysis tools to figure out the circumstances which were not obvious when condensation was happening. And then we got together with the project team to figure out how we could remediate that. Another example of building science that was particularly challenging in the Washington, D.C. area was a pool structure for a condo association that was suffering from deterioration of roofing and interior finishes. And we figured out how containing that humidified environment was really devastating the enclosure. And we worked out a clever solution so that it didn't require a great expense on the part of the condo association, but eliminated the potential for condensation in that environment.
What was the solution?
Put a very strong vapor retarder on the inside face of the assembly to block any of that very hot and humid air in the pool from reaching a plane where it could condense.